Tracking is to track a spectral component as function of time and extract its signal characteristics such as frequency, amplitude, and phase from its block-to-block FFT. The M2 menu is to select the type of signal characteristics to be extracted such as peak RMS, composite RMS, frequency, phase and so on. Peak RMS is the RMS of the largest PSD peak within tracking band. Its computation includes the largest peak plus minus so many frequency bins around the peak, which is specified in this text box. The next tracking type is CRMS, which is composite RMS over the entire tracking band. The next one is frequency, which is the frequency of the largest PSD peak. Frequency over N is the frequency of the largest peak divided by the corresponding RPM in reference window. Relative phase is the phase difference of the largest peak between the tracking channel and the reference channel as selected in the reference channel button here. Absolute phase is the raw FFT phase of the largest peak extracted at each tracking block. Signal-to-noise ratio represents the largest PSD peak above nearby noise floor. Amplitude over ref is the amplitude ratio of the largest peak between the tracking channel and the reference channel. In addition to M2 menu, tracking also has an extra M3 menu which is for tracking band selection. The tracking band can be a variable band or fixed frequency band. For fixed frequency band, simply enter the start and end frequency in these two boxes. For variable band, it requires the reference window be generated first. For example, if we want to track the 6N1 component, first select tracking type, peak RMS, frequency, and relative phase tracking. Next select tracking band. Since the frequency of 6N1 is changing with RPM, the desired tracking band would be a variable band centered around 6 times N1 in the reference window, plus minus so many Hz. To set up such tracking band, first turn on this radial button for variable band. Then from this RF pull-down list, select N1 as the reference frequency from reference window. Select multiplier 6N as the center frequency of the tracking band. Also in this text box, enter 20 Hz as the bandwidth of the tracking band. The unit of the bandwidth can be N, or Hz, or frequency bin. This completely define the variable tracking band which is 6 times N1 plus minus 20 Hz. Now click Start to start 6N tracking. This plot shows the resulting frequency, peak RMS, and relative phase tracking of 6N component. To change to different RPM such as N2 in reference window, from this RF pull-down list, select N2 as the reference frequency. And these harmonic buttons, N, 2N, 3N would now represent N2, 2N2, 3N2, and so on. In order to track any component whose frequency is non-integer multiplier of RPM, such as 5.2N, click on this any N button to turn it on, and then enter 5.2 in this text box. Also notice that, by clicking on this double right arrow button, these harmonic buttons from N to 10N will change to the next group of higher harmonics from 11N to 20N and so on. Clicking on this double left arrow button will return to the lower harmonics.